The James Webb Space Telescope JWST, considered humanity's most sophisticated astronomical instrument, has once again exceeded expectations and pushed the frontiers of what was once deemed unachievable in a discovery that has both stunned and energized the scientific community. The telescope has captured striking visual evidence suggesting the presence of a possible alien life form on Proxima b, a planet orbiting the red dwarf star Proxima Centauri, located a mere 4.4 light-years from Earth. This extraordinary finding marks not just a significant advancement in astronomical observation, but also reignites one of the most fundamental existential questions. Are we alone in the universe? Proxima b has long been a focal point in the search for extraterrestrial life, largely because it lies within the habitable zone of its parent star. This region is defined as the orbital range, where conditions might support the presence of liquid water, an essential ingredient for life as we know it. However, despite its relatively close proximity to Earth, Proxima b has been difficult to study due to the limitations of past telescope technologies that changed with the deployment of the James Webb Space Telescope, designed to probe deeper and with greater clarity into the universe than any of its predecessors. The JWST uses advanced infrared imaging capabilities to pierce the darkness of space and capture previously unobservable details. During a rare and fortunate planetary alignment, JWST focused its instruments directly on Proxima b, the high-resolution infrared images it returned revealed surface anomalies, unusual patterns, and reflective movements that deviated from known atmospheric or geological phenomena. These irregularities led to further scrutiny and, eventually, a sequence of time-lapse images that clearly showed a figure-like entity moving independently across the terrain. What made this even more compelling was the nature of the movement. The figure displayed deliberate changes in direction, periodic stops, and navigational patterns inconsistent with wind-driven particles, tectonic shifts, or fluid dynamics. Shadow analyses and light reflection angles indicated a structure that was humanoid or at least biological in nature. Importantly, this was not an isolated observation or an error. The entity was captured in several observation cycles under different lighting and planetary rotational conditions, thereby eliminating the possibility of camera artifacts or atmospheric illusions. This repeatability lends significant weight to the authenticity of the discovery. The consistency of its appearance, including interaction with the ground and casting of a shadow, suggests a physical presence that demands serious scientific inquiry. Proxima b itself is a rocky exoplanet slightly larger than Earth, with surface temperatures that, under the right atmospheric conditions, could support liquid water. The potential presence of a mobile, sentient entity on such a world adds an entirely new dimension to the way scientists understand the emergence and diversity of life in the cosmos. If this figure is confirmed to be biological or technological in origin, it would be the first direct visual evidence of a non-terrestrial being. This would shatter long-held scientific assumptions that alien life could only be inferred through indirect signatures or theoretical models. Notably, the James Webb Space Telescope was not specifically designed to detect alien life. Its primary missions include studying the formation of stars, exploring the early universe, and analyzing the chemical compositions of exoplanet atmospheres. However, this unexpected finding positions the telescope at the center of what could be the most transformative scientific breakthrough in modern history. Should this figure be confirmed as a sentient extraterrestrial being, it would fundamentally reshape the field of astrobiology, forcing a re-evaluation of our understanding of evolution, survival mechanisms, and intelligence in conditions vastly different from those on Earth. Scientists have previously theorized that life on Proxima b would need to adapt to the planet's frequent exposure to intense stellar flares from its red dwarf star. This would likely require either sophisticated biological defenses or technologically advanced sheltering mechanisms. The detection of a mobile, self-navigating entity implies that it has either evolved biological traits to endure these extreme conditions or developed technology capable of offering protection. This supports the broader idea that life and even intelligence can thrive under environmental parameters far removed from those of Earth. Adding to the intrigue is the nature of Proxima b's environment. Unlike Earth's sun, its star is much cooler and emits primarily in the infrared spectrum. Any indigenous life form would likely possess visual systems adapted to perceive this unique light, and its metabolic processes might depend on energy sources unfamiliar to Earth-based biology. The figure observed could belong to a completely novel evolutionary lineage, with biochemical and physical structures unlike anything humanity has encountered. The sheer repeatability of this phenomenon, witnessed multiple times under various planetary conditions, cements the legitimacy of the observation. This entity casts shadows, reflects light, and interacts with the surface in ways that indicate it is not simply a drifting object or optical illusion. Its continued presence and movements provide an essential foundation for future studies aimed at understanding its nature, behavior, and place within the broader narrative of cosmic life. This groundbreaking detection also raises important ethical and philosophical questions. Observing what could be a living, possibly intelligent being from such a great distance and without its awareness introduces new complexities in how humanity conducts space exploration. If the entity is aware, is it conscious of our surveillance? While the James Webb Telescope is a passive observer, it has no capability to broadcast signals. Its role as an unseen witness invites reflection on the nature of contact and the moral responsibilities that accompany superior observational technology. Furthermore, this sighting invites reconsideration of the so-called Fermi paradox, which questions why, despite the high likelihood of alien civilizations, humanity has not yet encountered them. Perhaps extraterrestrial life is not absent, but concealed, having evolved to thrive in obscure corners of the galaxy. It may not emit radio signals or build megastructures, but instead exist quietly, harmoniously with its world. The Proxima b figure might be biological, mechanical, or a hybrid of the two. It could be a living organism, a robot sent to explore its world, or even a sentinel artifact from a long-lost civilization. Each possibility carries staggering implications. If it's biological, it supports the idea that life has independently emerged elsewhere. If it's mechanical, then somewhere out there is or was a technologically advanced society. If it's a hybrid, we may be looking at an entirely new model of life. Whatever its form, this discovery demands a shift in scientific priorities. No longer can the search for extraterrestrial life focus solely on chemical markers or microbial extremophiles. The focus must now broaden to include high-resolution direct imaging, long-term behavioral analysis, and comparative studies of biology across planets. Scientific institutions will have to reallocate resources, redefine missions, and launch dedicated programs to follow up on this unprecedented find. The implications of this moment extend far beyond science. This could signify the dawn of a new era in space exploration, one where we no longer speculate about life beyond Earth, but begin to understand how to coexist with it. Our conception of humanity's place in the cosmos may transition from one of solitude to one of interconnectedness. Even incomplete, this knowledge compels a re-examination of our responsibilities toward Earth, our strategies for future interstellar missions, and our preparedness for potential contact perhaps within our own lifetimes. This development also transforms how we view telescopic observation itself. The James Webb Telescope is now more than a scientific instrument. It has become a witness to life beyond Earth. If the images continue to be verified, they may enter the annals of history alongside the first photos of Earth from orbit or the moon landings. But this time, we are looking not at ourselves, but at something wholly unfamiliar. The sighting forces us to reconsider the universality of life's emergence. Earth's evolutionary history has been shaped by billions of years of chaotic forces, from volcanic upheavals to asteroid impacts. If life has also emerged on Proxima b, then those chaotic forces may not be a rare exception. They may be a universal rule embedded in the laws of matter and energy. Life, it would appear, maybe not just possible, but inevitable under the right conditions. The James Webb Space Telescope's achievement is the culmination of decades of engineering, scientific curiosity, and visionary ambition. By capturing what appears to be a sentient figure moving purposefully across the surface of a world beyond our solar system, it has demolished the boundaries of known scientific exploration. This moment changes everything. The figure on Proxima b is more than data. It's a symbol of a broader cosmic reality waiting to be discovered. It challenges every institution from space agencies to universities to respond with urgency, innovation, and imagination. Simulations will be updated, theories revised, and missions launched as humanity moves closer to understanding the true nature of the universe.